Okay, taking a look at inverse of radical function. So as a reminder, to find the inverse, you have to switch the x and the y. And then you have to solve for y to get the inverse. Okay, so let's take a look at this function, first of all. In order for a function to have an inverse, it must be a one-to-one function. Okay, so I'm going to explain what a one-to-one function is right now. So let's go ahead and graph this. The simplest way to determine if a function is one-to-one is, does it pass, first of all, we know this is a function because it passes the vertical line test. It only touches it in one place vertically. Now if I draw a horizontal line, we can determine if it's a one-to-one function. If I draw a horizontal line anywhere on this graph, it will only touch in one place. So this is a one-to-one function because it passes not just the vertical line test, but it also passes a horizontal line test. It only touches it in one place. So a function has an inverse function if it is a one-to-one function. Okay, so let me write this down. One-to-one function passes horizontal line test. Okay. Also, the domain is constrained on this function from -2 to infinity. So the domain is x is greater than or equal to -2. Let me write that down here. I'll write it again after I find the inverse. Actually, let me write it here. So that's the domain. The range is going from 0 to infinity, so x is greater than or equal to, or y is greater than or equal to 0. Now this is going to be important once we get to our inverse. So switching the x and the y, this represents y, so that's going to be x. Okay, now we want to solve for y, so we're going to square both sides. And to denote inverse, we use the -1. And our original is in function notation, so the inverse function of x. Okay, so now since this is our inverse function, to determine the domain and the range, the domain of the inverse function is going to be the range of the original function. But of course, we're going to use x instead of y. And the range of our inverse function is going to be the domain of our original function. Now this is going to be important because remember, inverse is all about switching x and y, and domain represents x. So x becomes y. Range is y, y becomes x, so they switch spots. Okay, so let's take a look at this graph. And to To get another graph, since we already have one on here and we want to put another one, we can press Tab and it'll open up a second function window. So let's put our new one in. So we have x squared minus 2. All right, let's take a look and see what that looks like. Okay, so notice it gives us the whole graph, the whole parabola, but we don't want the whole thing. We want to constrain it. We want the domain to be only values greater than or equal to 0. So let's go on to our function here. If we slide this cursor up, and once we get on that equation, double click. All right, and then we're going to do control equal. Remember, we have to put the bar first, and then we want x control equal, and we want greater than or equal to, and 0. Okay, now let's graph it. Okay, so here is our original function, and here's our inverse function. And if you'll remember, the line of symmetry, or I should say the line of reflection, for these two graphs, let's go ahead and open up another tab. Third function is y equals x. And if we graph that, we have our line of reflection. So notice that it's reflected over this line. Okay. And I think that will do it. Just in time. That's the 6th period bell. I'll see you all in class tomorrow.